Okay, so today we're going to go over 9.4 extension, and this is all about choosing a method for solving. So right off the bat, let's go ahead and write, this is our title. You can pause the video now if you need some time to do that. However, I'm going to dive right into it. So there's 5 different methods, okay? So here are the methods. And this is going to be a bit of review, okay? So method number 1. So the first method that we want to use, and the first one we want to look for when we're solving a quadratic, actually let's go ahead and label this a little bit better. Methods for solving quadratics. Okay? And then let's do a little reminder of what a quadratic is. So a quadratic is anything that can be written in this form right here. Okay, so our first method is actually the first thing that we learned about it. In fact, we didn't even learn about it in this chapter, and we didn't even learn about it in the last chapter. We learned about this in chapter 7. In fact, chapter 7, half of it was all about this, and that is factoring. So factoring was our first method for solving quadratics. And this is actually going to be the first method that you want to use, okay? So first I'm going to tell you the method, and then I'm going to tell you when you should use the method. So this is when you should use the method. So you're going to want to factor something so use this method when a equals 1. So that's the first part. And basically, if a equals 1 and you have b and c to where they can factor easily, where it's easy and it's easy to tell what adds to make b and multiplies to make c. Okay? So this is when we want to use factoring. When a is equal to 1, that way we don't have to do the big, you remember that big 3-part table that we'd have to make? That table is really confusing, so let's just try and avoid that as much as we can. But factoring whenever a is equal to 1, so basically when the function looks like that's a lot easier to factor, especially if we already know something, combination that adds to make b and multiplies to make c. So let's do an example. Here's an example of, let's say example A. Here's an example of a time that you would want to use factoring. So first off, we always want factoring to be equal to 0. So 0 equals, let's do x squared. Notice that there's no a value in front, so that means a equals 1. So that's good. Plus, I'm just going to make something up off the top of my head. So I'll do 7x plus 10. Okay, the reason why we want to factor this is because it's actually really easy to spot what adds to make 7 and multiplies to make 10. And the answer is 2 and 5, because 2 plus 5 makes 7. 2 times 5 makes 10. Remember, the thing that you want to check is not what adds to make 7. You want to check what the multiples of 10 are. So there's only 2 possibilities. There's 1 and 10, which I know 1 and 10 does not add to make 7. But then there's 2 and 5, which I know does add to make 7. So it's a lot easier to check the c value first, okay? So that'll be the note that I make over here. Check c value first, okay? So we're going to check the c value first, figure out what 2 things add to make 7, multiply to make 10, and then I'm just going to write the factored form. X plus 2, x plus 5. And so this is factored form, okay? And then once we factor it, now we can do the split. We can do x plus 2 equals 0, x plus 5 equals 0. So we got the split here. X plus 2 equals 0. And then over here we've got x plus 5 equals 0. Okay, and we solve for each one. Minus 2, minus 2, minus 5, minus 5. And we get x is equal to negative 2, or x is equal to negative 5. Okay? So that's when you would want, this is when you would want to use the factoring method, when you can see that a equals 1. In other words, there's nothing written right here, and it's easy to tell what adds to make 7, multiplies to make 10. Okay, so factored form is always going to be the easiest thing to do, because notice how fast that was. That was really fast to solve this. Okay, let's move on to the next one. So the second method, and this one I would actually avoid at all costs if I were you, but it is effective for one case, and that is graphing. Okay, so this is my suggestion. This is not what the book says, but honestly, this is my personal opinion. I think graphing is the worst method to use. It's not very accurate. The only time it is actually accurate and easy to find the answer is if the answer is the vertex. So if the answer is the vertex, then it's really easy because you know you have one solution and it's really easy to see what that solution is. So graphing only use if vertex is the answer. Now, the hardest thing about this is you don't actually know just by looking at a problem if the answer is going to ends up being the vertex, right? It's almost hard to tell. The one way that we can tell is if it's the vertex, we know that there's going to be one solution, and we just learned last chapter that the discriminant actually tells us if we're going to have 1, 2, or 0 solutions, right? So remember that our discriminant is always b squared minus 4ac. So check the discriminant, and if the discriminant is equal to 0, then you have one solution. Therefore, you know that the graph is going to look something like this, right? When you have one solution, it basically means that your only solution, your one solution, is going to be the vertex, right? Okay, so my suggestion to you is, honestly, I would just stay away from this method. However, if you're looking for a second method, because in your homework you're going to have to find 2 methods to use, and if you really don't want to use any other method, this is an option. Okay, so you can check the discriminant real quick and see if it's equal to 0. If it is equal to 0, then this might actually be kind of a nice method to use. So let's do an example. So example B shows that I have, I'm kind of just making these up as I go. Let's do 2x squared. And for the b value, I'm going to have to make it an even number. Let's say it's, sorry, I should have thought about this ahead of time. Let's say it's 16x, okay? So if it's 16x, then I need my last value, 2 times 4 is 8 times 2 again, equals 16, okay. So let's say you have this set as your example, right? So if I'm looking at this, I might look at this and say, oh, I don't really want to factor this because I don't have an a value of 1. Maybe I want to try graphing. So what I'm going to do real quick is I'm going to check the discriminant. So d equals b squared. So b squared for this is, oh, I think I messed up. I think this was supposed to be a 4. Sorry, you can scratch this out and write 4 instead. That makes way more sense. Okay, so 4. So 4 squared minus 4 times A times C. Okay? And then now let's solve this. So 4 squared is 16 minus 4 times 2 equals 8 times 2 equals 16. So 16 minus 16 equals 0, which means this works. So I can actually find, all I have to do is find the vertex, that means, okay? So let's find the vertex. And if you remember right, the x value of the vertex is going to be equal to b over, or sorry, negative b over 2a. And if you notice, this is actually the quadratic formula without the plus or minus square root of b squared minus 4ac. And the reason why we can skip straight to this is because that part's just going to go away if I already know the square root of all that is equal to 0. So this is actually the quadratic formula, just really simplified because we only have one solution, which is kind of nice. So now we've got x equals negative b, so negative 4 over 2 times a, which is 2. So the answer here is negative 4 over 4 equals negative 1. Now what I can assume, since my discriminant was equal to 0, this is actually the answer right here. X equals negative 1. It's the only answer. In fact, if you don't believe me, go ahead and plug that in to this. You can pause the video if you need to. Plug this back into this and see if you get 0 as your answer. If you do, you know that the graph is going to look like this. It's going to look like something where the vertex is touching the x-axis, which means there's only one solution. So my answer here is negative 1. X equals negative 1. So this is the only time I would ever use this method. To be honest, I think this is the worst method. So this might be something that you just skip and don't really do that often. But if you need a second method, you can use this, okay? And we might do a couple examples where I use this method later. Okay, so we'll come back for the next 3 methods.